Hello student, welcome back to our trigonometry class. In our last class we discussed about the sine rule, which can as well be referred to as the sine formula. So today we are looking at the cosine rule, which could also be referred to as the cosine formula. So as we know that the sine and the cosine rule are basically used for solving problems on triangles. That is, we either use it to find the angles or the sides of a given triangle. Now, what is the cosine rule used for? The cosine formula is for solving triangles, not right-angled, in which two sides and the angles between the sides are given. Now let's look at example as regards this. Now suppose we have a given triangle ABC, which is acute angle and obtuse angle triangle. The cosine formula is expressed as, before we write the formula, let's try to label the vertices of this triangle. That is, we can call this A, while this is B, and this is our angle C. You remember that the side opposite the angles are labeled in lowercase letter A, and this will be B, this as C. Now, to compute the sides A, B, and C respectively using the cosine formula, we use either of these equations. For our cosine formula, we have that the side A squared is the same as B squared plus C squared minus the product of 2 and the BC as minus 2BC cos the angle at A. So we use this formula to find the side A, if that's what we're looking for. Also, if we want to compute the value of side B, we have that the square of B is equals to A squared plus C squared minus 2AC cos the angle at B. And to find the side C, we have that C squared is equals to A squared plus B squared minus 2AC cos the angle at C minus 2AB cos the angle at C. So we can use these equations to calculate the sides of a triangle which is acute angle triangle or an obtuse angle triangle using the cosine formula. So suppose we have the angles to calculate. We simply try to make uppercase letters here, A, B, C, the subject of formula. That means we can rewrite the cosine formula when we want to try to calculate the angle as we can have A, or let's say we have cos A as B squared plus C squared minus A squared all divided by 2BC. Then our A can be the arc cos or the inverse of the cosine of this whole thing. So we obtain this by a very simple change of subject or formula. So we can also have that cos the angle at B, or the cosine of the angle at B, is the same as A squared plus C squared minus B squared all divided by 2AC. So lastly, if we need to calculate the angle at C, we can use C cos C as A squared plus B squared minus C squared all divided by 2AC. B. So you can write cosine formula in this form when we're trying to find the sides, and to calculate the angles using the cosine formula, you can write the same cosine formula as this by changing the subject of formula as cos A equals to this, and the final value will be the cosine, the inverse of the cosine of the whole of this, or the inverse of the cosine of the whole of this for angle B, and for angle C we find the inverse of the cosine of this. So let's look at some examples as regard the cosine formula.